Hi, welcome to another video in my series on summing series using sigma notation. And in the previous videos in this series we've looked at the sum of r and then the sum of r squared, and in this one it's the turn of summing terms of the form r cubed, where r goes from 1 to n. And it can be shown by mathematical induction that the sum of r cubed going from 1 to n is equal to n squared divided by 4 all multiplied by n plus 1 all squared. So if you would like to see a proof of this, as I say, by mathematical induction, just go on my website and look under mathematical induction in the index and you'll find, as I say, a proof on this. So this particular video is very similar to earlier ones in the series, only we're dealing with terms in r cubed. So if you've been watching those, you might want to try these three examples. Okay, well, welcome back if you did have a go at these, and let's just work through them. For the first one, this is just a basic one just to get us into what the sum of r cubed is all about. And in this case we're summing r cubed going from r equals 1, so that'd be 1 cubed, plus, and then when r is 2 it'd be 2 cubed, and then 3 cubed, and so on, all the way up to 8 cubed. And then we can just substitute n equals 8, because we've got 8 terms here, directly into this formula. And then we're going to get 8 squared over 4 multiplied by 8 plus 1 all squared. And if you work this out, you'll find that you get 1296. And you could verify that this formula works, rather than just assuming it does, just by checking out 1 cubed plus 2 cubed, etc. on your calculator and checking that it does indeed come to 1296. Okay, well that's number one, very basic question. I picked number 2 because in this example we're going from r equals 1 not to n but to 2n, 2 big N here, okay? And we're also summing not just r cubed but 5r cubed, a constant times the r cubed. So whenever you get a constant in front of a value of r like this, we have seen in the past that what you can do is pull that constant out of in front of the sigma sign. So we've got 5 times the sum of r cubed, where r goes from 1 but not to n this time but to 2 big N. But all that changes really is that it's going to be 5 times the result that we get when we substitute in place of n 2n. Okay, so we've got 5 times 2n all squared divided by 4, and that's multiplied by 2n plus 1 all squared. Well, 2n all squared is 4n squared, and you could divide by the 4, so it just leaves you with n squared there. So 5 times n squared multiplied by 2n plus 1 all squared. And I'd leave it like that, okay? Now, example 3. What I've got here is a series then which is based around the sum of r cubed, because what we've got here is essentially a common factor of 3 multiplying the sum of r cubed, where r goes from not 1 but from 5 for the first term all the way up to 10 for the last term. So to do something like this when r doesn't start from 1, as we've mentioned in the earlier tutorials in this series, all you need to do is first of all think about the summation of r cubed, in this case going from r equals 1 all the way up to 10, but then you need to subtract 3 times the summation of r cubed going from r equals 1 up to the one before this term. In other words, up to n equaling 4. Now all we need to do now is just work out what each of these are. So for the first one we've got 3 times, and then we're doing sum of r cubed where n is 10, so it's going to be 3 times 10 squared over 4, and then multiplied by 10 plus 1 all squared. And then for this second term it'll be minus 3, and n in this example is 4, so it's going to be 3 times 4 squared all over 4 multiplied by n plus 1, or 4 plus 1 all squared. And if you work this out, you'll find that you end up with 8,775. And again, you could verify that this is correct because you haven't got too many terms here, so you could easily just type this into your calculator and, as I say, check that you get that answer. But this method really is designed for whenever you've got a lot of terms here, where it's going to be totally inefficient just to type this directly into your calculator. Alright, so this just shows you basically the principle that's involved. Well, I hope that's been useful to you, and in the next video in this series what I'm going to be doing is combining all the series that we've used so far, that is sigma r squared and sigma r cubed, and also the sum of a constant, and we're going to be looking at combining those in one particular summation. Alright, so I hope you'll have a look at that, especially if you found this one of use.